Your NestJS application works perfectly fine on your laptop, but in production, it might crash, leak data, or get hacked. So the worst part is most developers don't even realize it. Today, I will show you how to fix NestJS application and make it truly a production-ready platform. So what is the problem? Let's be real. Most of the NestJS tutorials stops at CRUD operation, basic fundamentals, no validation, no security, no logging, no observability, no API limiting and all. And you deploy it, suddenly user sends invalid data, API slows down, errors are impossible to trace, we don't have a error tracing, configuration management, logging, observability, nothing is there. So step one is you have to structure your application, add validation, security, logging, error handling, environment management, configurations, performance and scaling, production checklist before even you deploy it to production, right? Validation is there, authentication has been implemented, logs are working, proper errors are handled, rate limiting is handled or not. So in this video, we are going to all those things. What most developer thinks that their application is ready until production proves them wrong. Don't be that developer. If you want a full production ready application, then this video is for you. So what are the checklist for NestJS application in production? Let's say you write a simple application which doesn't have validation, no authentication, no logging, rate limiting, or error handling. You will see your application will not work in production, right? So first thing which you should do to make your application production ready is structure your application as a system, right? Proper folder structure, domain, repositories, inside domain, particular folder, their DTOs, controller, services, the DAOs layer and all, everything is structured, right? So you use the NestJS building blocks, define controller, services, repositories, DAO and module properly for a particular domain. Validation and security. You should use the validation using validation pipe, HTTP level security using Helmet, authentication using guards, role-based guard or token-based guard. Error handling and logging. You can actually use a structured logging using Winston, Pinot or CloudWatch logs or something, verbose logs. You should have a global exception filter or request interceptor. Why we need it? So that we can get the proper exception which is coming. Config scaling and performance. Config, you should have a configuration management in SCS config. You can have the configuration separated by environment, development, staging, and production. For performance, you can have a cache module for the scaling. At a small application, you can use a bool MQ and all. So this is the overall checklist which we have in this validation enabled properly, auth implemented, structured logging, rate limiting, exception filter, database connection pooling. That is really important, that you should not end up creating 200 300 connections for just a one tiny application. You should use a connection pooling, health check, documentation, structured logging, proper folder structure, authentication, all the middleware on the app instance to add on the security like Helmet and the rate limiting or throttling, validations enabled globally, so you should not be just passing random data. So all those things are really needed for the NestJS application. Hi everyone, and let's talk about production checklist. So when you are building a NestJS application, we say that NestJS application is production ready, then we need to make sure that this checklist is green mark. Validation, class validator, validation pipe, Jod, Joy, whatever you want. Security header, we need to use a Helmet middleware, like a Helmet is a NPM module which we can use. Rate limiter, we can use a NestJS throttler. Cross origin resource sharing, just return the proper cross origin headers. You can configure the origins at app middleware level. JWT authentication, we should return access token and return, and also enable the refresh token feature. Logging, we should use Winston, Pinot, and like it depends on where you are deploying your application, on ECS container or Kubernetes or a Lambda or a VM. You should have a logs enabled. Error handling, global exception filters either at a controller level. Configuration management, you can use a NestJS config or write your own custom config service. Caching, Redis or cache manager. Queues, you can use a bool MQ for bulk asynchronous processing. Health checks, you can use a health, ready or live API. API docs, Swagger and all. Compression, gzip should be enabled. Graceful shutdown, that when you stop your application, your resources should be destroyed, like database connection, instance and all those things. So these are like a production checklist. This is also same as making your application with the 12 factor principles. I mean, It's like you're building a microservice, you are going to deploy it as a Lambda or a VM. So what are those 12 factor principles? So your application should support all the 12 factor app. This is simple for any microservice. Code-based dependencies, config, backing service, build, release, run, processes, port binding, concurrency, disposability, dev, prod, parity, logs, and admin process. I mean, these terms are self-explanatory because one code base track the revision, control, many deploy dependencies, explicitly declare your main dependencies, dev dependencies, config, store config in the environment, and how you inject the configurations at the runtime. Okay, build a release process. Okay, so port binding, concurrency, and all those things. So these things are easy to add because we will be using these existing modules. App.use helmet to introduce security headers. Rate limiting, you can introduce a throttle module. For cross origin, you can actually enable the cross origin resource sharing. You can specify the origin who is going to call your APIs. JWT authentication, for public API you can use public, and all the private routes you can define the guards, right? Role guard, auth guard. Validations will use validation pipe which will check or sanitize all the request body parameters or request parameters. Logging, you can use Winston Pino, or any kind of a third party platform like a CloudWatch logs when I'm deploying my NestJS application as a Lambda. Error handling, we will be using HTTP exception filters and all. Performance, you can use a cache manager Redis, which is storing all the caching, storing all the key value pair, right? BoolMQ, when you wanted to send a bulk processing like sending bulk email, you can use BoolMQ. Now API documentation, you can just use Swagger. It's really a rich module which will expose your APIs through the Swagger documentation. Docker setup, environment variables management. You can manage your environment variables secretly either through SSM, on AWS, through the environment variables, on your GitLab and GitHub Actions, right? So to make your application production ready, these are the basic things. Add a security header, enable cross origin, enable the compression, use validation pipe, and specify that disable error messages, transform options, forbidden whitelisted. Throws error for any additional or extra properties which you are sending in the payload. This is how we enable Swagger for a particular environment. Enable shutdown hook, graceful shutdown of your application. And now if you talk about the app module, it has all the root module definitions like config module we have, throttle module, cache module, and all the domain modules. So we have domain modules, user module, auth module, health module, queue module. So this is a root module, and now this root module is dependent on these sub modules which are like queue module, health, user, and auth. Okay, and we have introduced, if you look at the code, we have all the common things which we need like the filters, pipes, interceptors, and all. Config, because we are using config loader. This is app config, database config, JWT config, Redis config. So we should be able to start the application only when all these configurations are loaded properly through the process.env. There is also one way to manage the environment variables. Throttle module, you can rate limit the APIs. And then cache module, caching with Redis, it's just to improve the performance of the repetitive HTTP calls without changing in the response if you wanted to get it. Cache module. And these are the global exception filters like filters, interceptors, global pipes. You can register them at the different places, at the controller file, at so this is a module, right? You can also define the interceptors, middlewares, filters, or in the main.ts. There are multiple places. It depends on you how you want that interceptor to be applied, at the controller level or maybe at the module level, all those things. So this is finally our main.ts, throttle config, all these configs, and this is the interceptor. So to make your application production ready, you need to have a rock solid foundation. So if you want to make your application production ready, then basic things I will explain is: first mistake, bad project structure. Don't do that. Create separate module, their inbuilt things, controller, services, DTO, DAO service. Keep DTOs clean and validated, right? What add validations and security? Use global validation, use class validator validation pipe, helmet, rate limiting, cross origin logging, and error handling. We can use different kind of a logging. We can export these logs to the third party platform where we can visualize config module performance. We can use caching, compression, database optimization, how database is performing, all those things. So most developer thinks that their application is ready, but until production proves them wrong, don't be that kind of developer. Always try to see what you're doing. Right? Docker compose file is just to bootstrap the Redis container, Redis commander, or the Postgres container, because we are dependent on the database, we are dependent on the Redis. So we need those modules. We need those containers. When you do Docker compose up, I will be able to have a Redis and Postgres, and then I can use them. So how we are exposing based on the host and the container port. I think the host and container ports are same on the Redis. So we are good. So we should be able to connect it like this. So when you are creating a baseline, you should also always take care of all those things, that we have app module, root module, introduce all the things like config module, DynamoDB module, Postgres module, TypeORM module will all go inside this. If you have a multi-level hierarchy, then we will think about it, like cache module, throttle module. Then now we have a auth module. So inside auth module, it will have its own controller services, DAO services, and all those things. So this is how we can make our application production ready. I don't have many modules, but this is how we can define different modules. Like this is the auth guard, because I added a auth module, auth guard, auth strategies, auth controllers, auth module, auth services, which are doing the same thing. Either we use them plain or we use them with the passport strategies to log in the user. So this is all about how you can make your application production ready with all those things together and test it. Swagger is going to provide a API documentation so we can test once that is deployed.